Hello and welcome to the NumPy assessment quiz solution. So same as with the Python basic quiz, we have 15 questions that cover all topics we need for our sticker album case study. And if you have the impression that you need some more background on the basics, feel free to watch the next few sessions about the basic NumPy coding. And for all questions we have the assumption that we already imported NumPy. So let's start our quiz. And here the key message of the first question is that a NumPy array only contains one data type, and by converting a list with different data types into a NumPy array, all elements are converted to one data type. Actually to the lowest common denominator, and in this case it's the data type string. So with quotation marks we can transform an integer, a bool and a float to a string. So the correct answer is string only. Here in this question we have a NumPy array with 5 elements, and we have a so-called vectorized or element-wise operation, and where we add 10 to each element. So actually we should get 11, 12, 13, 14, 15. So this is correct here. And the key message is that in contrast to lists, element-wise operations work pretty easy here with NumPy. So here we have two codes, and we should determine how many of these codes return the output 6, 9, 12, 15, 18. And let's have a look at the code 1. So also here we have an element-wise operation where we first add 2 and then multiply with 3. So let's start with 0 plus 2 is 2, times 3 is 6. Then 1 plus 2 is 3, times 3 is 9. 2 plus 2 is 4, times 3 is 12. 3 plus 2 is 5. Times 3 is 15, and 4 plus 2 is 6, times 3 is 18. So code 1 works, and let's have a look at code 2. Here we have the function np_arrange, and np_arrange arranges integers in the range from 6 including till 19 excluding, and only every third element. So we are starting with 6, then we have 9, 12, 15 and 18. So also code 2 produces this output here. So the correct answer is both. So here in this question we have a NumPy array with 10 elements, and we are slicing from the index position 4 including till the index position 8 excluding, and also here the zero-based indexing applies. So we start here with 0, 1, 2, 3, 4. So our first element of our slice is 5. 5, 6, 7, 8 excluding. So our last element in our slice is 8. So this should be here the correct answer. Here we have a NumPy array with 5 elements, 10, 20, 30, 40, 50, and we assign the variable array A, and then we make a slice of array A. So we take the first 2 elements and assign the variable array B. So array B contains of the elements 10 and 20, and then we change the first element of array B and set it to 1. Then actually, so this answer here is correct. The first element of array B is now 1. And actually here with NumPy arrays, when we create here a slice of array A, we are not creating a copy. So array B is referencing to the same original object, but only to the first 2 elements. And if we change one of the first 2 elements of array B, we also change the elements of array A. So array A, the first element of array A is now 1. And if we want to prevent this behavior, here we have to make a copy of array A. So this is a common source for mistakes actually. you make a slice and change an element in a slice of a NumPy array, and then also the original A changes, and you might not even recognize it. So this is important here. Okay, the question here says which statement is incorrect. So incorrect is that the first element of array A is still 10. So now this is correct. Here we are creating a one-dimensional array with elements from 0 to 7, and then we reshape the one-dimensional array to a two-dimensional matrix with 4 rows and 2 columns. So here we have 4 rows and 2 columns, and this is the correct answer. Here we have a matrix, a two-dimensional array with the shape 3, 5. So we have 3 rows and 5 columns. And yeah, we want to index 7. So here this row is at index position 0. And the second row is at index position 1. So let's move to the column. Here is column at index position 0, column at index position 1, and column at index position 2. So row at index position 1 and column at index position 2 should slice for 7. Again, we have the same matrix, and yeah, this is kind of a tricky question. So we slice the matrix, we take all rows and the column at index position 2, so this is this column here, and then we add 100 to each element. Yeah, and if we would print this line of code here, then we would end up with this answer here. But actually here with this code we are not changing the matrix itself. So we are not assigning new values to the column at index position 2. So actually we haven't changed the original matrix at all, and the correct answer is here the first one. So the matrix, my matrix, is unchanged. Here we want to create 20 random integers in the interval 1 to 10, both ends including, and we want to select all elements that are greater than 5, and we set the random seed to 1, 2, 3 to ensure reproducibility. And let's have a look at the answers. So we want to create 20 random integers in the interval 1 to 10. So the starting point is including and the ending point is excluding, and we need to have 20. So here this is correct and also this is correct, and the second answer is not correct here. And now the second key message of this question is Boolean indexing. So if we have a look here at this answer, then for each of the 20 random integers, we check whether the integer is greater than 5, and then we create here an ND array with 20 booleans and print here the ND array with booleans. But actually we do not get here the integers which are greater than 5. So here in the first answer, we have a Boolean indexing. So we select all elements of our array with 20 integers which are greater than 5. Here we calculate integers to the power of 3 with list comprehension and NumPy code. And the key message is that for large numerical operations, like in this case here, NumPy is 50 to 100 times faster. So the fastest code should be here the NumPy code with only 1000 calculations. And here for code number 1 and 2 with the same amount of calculations, so we have 100,000. Here the NumPy code should be much faster. So answer 3 to 1 is correct. Here we have a NumPy array from 1 till 20, and we want to create a new array that contains all elements that fulfills 2 conditions. So first of all, the element must be divisible by 3 without remainder. And the second condition is that the element 3 must not be in the array. So we have 2 conditions and both must be met. So we need here an AND sign. Here we have an AND sign, here we have an OR sign, and here an AND. So this is not the correct answer. And what we need here is Boolean slicing. So This answer is incorrect as it returns only the Boolean array showing for each element of the array here if both conditions are met, but the answer here does not return the elements itself that fulfill both conditions. Here we have two conditions. They are linked with an AND, and then we are creating us here a Boolean array with truth or false for each element, checking if each element fulfills both conditions, and then we slice the array only for the elements that fulfill both conditions. So this answer here is correct. Here we create 10 random normal distributed numbers with mean 50 and standard deviation 10, and we calculate the mean over these 10 numbers, and we repeat this process 1000 times. So we have 1000 simulations, and in the end we want to return an array with 1000 mean values. So the question is how many of the following codes are correct? And until here all three codes are identical, so we create 10 times 1000 normal distributed numbers with mean 50 and standard deviation 10. So we have 10,000 normal distributed numbers, and in code 1 we reshape these 10,000 numbers into 1000 rows and 10 columns. And then for each row we take the mean over the 10 columns, so x is equals 1. So here we should get 1000 times the mean of 10 normal distributed numbers. And here in code 2, we reshape our 10,000 numbers to 10 rows and 1000 columns. And then we take the mean over all 1000 columns. So 1000 times over 10 rows. So also here we should get an array with 1000 mean values. And code 3 is actually identical to code 2. First of all, we reshape the 10,000 numbers into 1000 rows and 10 columns, and then we transpose the matrix into 10 rows and 1000 columns. And then, same as in code 2, we take the mean for each of the 1000 columns. So the answer is that all three codes are correct. Here we have an array with 7 elements from 1 to 7, and which code returns the output 4? So we have here in the middle the 4, and let's check what answers we have here. So we have percentile, the 90th percentile, we have the median, and we have the sum. So obviously the sum of the array cannot be 4. The percentile, actually also not really, and the median is actually here the value where 50% of the other elements of the array is less or lower than, and 50% is higher. So the 4 is the median of our ND array. And we can calculate the median with the NumPy function np.median. So here we have a function y equals cosine x plus x, and we want to plot the graph in the interval -10 to 10. And the question is which code best produces this graph. So let's have a look at our answers here. And to plot a graph we need many data points. So np-linspace creates us 1000 evenly distributed data points in the interval -10 to 10. And np-range actually only creates 20 data points from -10 to 10. So this is not the optimal answer here. And comparing answer 2 and 3, so there's in Python standard library no function like cosine. So we have to calculate the cosine with the NumPy function np.cos. And this should be the correct answer here. Now our last question. So we have two-dimensional data points represented by the ND arrays x for the x coordinate and y for the y coordinate, and we want to fit a linear regression line that best fits the data points. The right function for it is the NumPy function np-polyfit, where we pass the arrays x and y, and as we want to have a linear regression line, our polynomial degree should be 1 and not 2. So here we get a quadratic regression. So the best answer here is answer 1.